Imagine standing at the edge, not falling off, standing on ground that goes flat to the horizon and simply stops. Now start walking inward, and something impossible happens. The ground begins to tilt, not because it's sloped, it's perfectly level, but because gravity has stopped pointing down. By the time you reach the center, you'd be walking, effectively, uphill in every direction, on a world where the atmosphere has pooled into one enormous puddle, and the oceans have gone with it. A flat Earth wouldn't be a conspiracy. It would be a catastrophe with rules. And the rules are stranger than the myth. Let's do something the internet almost never does with this question. Take it completely seriously. Not as a debate, not as a debunk, as a physics problem. If you handed the universe a flat Earth and pressed play, what would actually happen? To answer that, we need one fact, the most important one in this whole episode. Gravity doesn't pull down. Gravity pulls toward mass. Every scrap of matter attracts every other scrap, and the direction of that pull always points toward where most of the mass is. On a sphere, this is tidy. No matter where you stand, the bulk of the planet sits beneath your feet. So down is the same experience everywhere. It's why the ground never feels tilted in Sydney or Reykjavik. Now flatten it. Take Earth's mass and spread it into a disk. Stand at the exact center, and things feel normal. Mass is distributed evenly around you, so the pull is straight down. But walk outward, and the disk stops being symmetrical. More and more of the planet's mass is now behind you, back toward the center. And since gravity points toward mass, your down tilts inward. Walk far enough, and it becomes severe. Near the rim, you wouldn't be standing on a plane. You'd be standing on what feels like a brutal slope, with the ground rising in front of you and gravity dragging you back toward the middle. The edge of a flat Earth wouldn't be a cliff you could fall off. It would be the top of an unclimbable hill, which means everything not bolted down goes to the center. Water flows to the lowest point, and on a disk, the lowest point in gravitational terms is the middle. So the oceans abandon the rim entirely and pile into one colossal central sea, kilometers deep, while the outer regions dry into exposed rock. The atmosphere does exactly the same thing. Air is held by gravity, and gravity points inward, so the air pools centrally too, thick and crushing in the middle, thinning as you move out. Somewhere along that journey it gets too thin to breathe, and further out, you'd reach effective vacuum. A flat Earth wouldn't have countries and continents. It would have one habitable ring, an inland ocean, and a dead, airless waste stretching to the rim. And that's before we ask the real question. Because there's a reason no large object in the universe is shaped like this. Take any big pile of matter, and gravity pulls all of it toward the center of mass, equally from every direction. That's a spherical instruction. Rock is strong, but it isn't infinitely strong. Pile it high enough, and the material at the bottom simply cannot hold the weight above it. It flows, slumps, and settles. Astronomers have a name for the point where gravity wins: hydrostatic equilibrium. It's the threshold where an object becomes round because its own weight overwhelms its structural strength. It's why small asteroids are lumpy potatoes, and every planet and major moon is a ball. Earth is far, far past that threshold, so a flat Earth wouldn't stay flat. Its own gravity would crush the disk from the edges inward. The material would flow, and within a geologically short time, it would collapse into the only stable shape available. It would become a sphere. Again. Now here's the twist most people never consider. Suppose we cheat. Suppose we hold the disk rigid with some impossible material and force it to stay flat. Now the sky breaks. Day and night stop working, the way any flat Earth model claims. On a disk facing the sun, either the entire surface is lit at once or the entire surface is dark. You cannot have simultaneous noon in one place and midnight in another on a flat plane facing a distant light source. Sunset would be impossible. On a sphere, the sun disappears because the ground curves away beneath it. On a flat plane, a receding sun would shrink into the distance and dim. It would never drop below anything. Seasons collapse too, because they come from a tilted axis on a rotating sphere, and time zones stop meaning anything, which brings us to the thing worth sitting with. The shape of the Earth was never settled by a photograph. Around 240 BC, a Greek scholar named Eratosthenes noticed that at noon on the same day, a stick in one Egyptian city cast no shadow, while a stick in another cast a clear one. On a flat Earth, under a distant sun, both shadows should match. They didn't. From that difference alone, he calculated the circumference of the planet and landed remarkably close to the real figure. He had no telescope, no spacecraft, no mathematics beyond geometry. He had 2 sticks, 2 cities, and the willingness to take a measurement seriously. That's the quiet lesson buried in this hypothetical. We don't know Earth is round because someone told us. We know because the alternative makes predictions about shadows, horizons, sunsets, and gravity, and those predictions fail the moment anyone checks. A flat Earth isn't wrong because it's unpopular. It's wrong because it's testable, and it loses. And you can still run Eratosthenes' experiment yourself with a stick, a friend a few hundred kilometers away, and a sunny afternoon. So here's tonight's question. If you could stand on that impossible disk for 1 hour, at the crushing center or the airless rim, where would you go? And what's one thing you believe right now that you've never actually tested? Every question creates a new reality, and reality is just one version of the truth. Every possibility deserves exploration. The next one begins with a single question. What if? Subscribe and explore what comes next.